Welcome to day 10. We're taking a look at volume and surface area today, along with three-dimensional figures. On the Regents exam, one of the very back pages that you'll have has a formula sheet. This is cut off from the formula sheet right here. These are the volume formulas that you will get on the test. So there's a few that you don't necessarily have, and they involve the fact that a general prism just has a formula of BH. So remember that the B part, the capital B part, is referring to the area of the base. That's what the capital B represents. And the same thing here, okay? So you need to figure out what shape the base is for these two formulas here. Okay, and then you're going to insert that formula in for letter B. Now, a cylinder, a sphere, and a cone all have a specific formula. So a cylinder, the base is a circle, so that's why it's the area of the base times the height, or pi r squared h. A sphere is just 4/3 pi r cubed. Remember that the surface area, we just get rid of the 3's, is 4 pi r, and then area is squared. So that is the surface area formula. The volume formula just involves those two 3's here, 4/3 and then pi r cubed. And the cone and a pyramid are both 1/3, okay, what the prism and the cylinder are. So 1/3 pi r squared h and 1/3 area of the base times the height. Now, if you're looking at a specific prism, okay, such as a rectangular prism, that's the area of the base, which is length times width times height. If it's a trapezoidal prism, remember it's 1/2 the height times the sum of base 1 plus base 2. And then you're going to multiply this times the actual height of the trapezoid. So there's two heights involved here, so you got to be careful. One's the trapezoid, one's the height of the actual prism. Sorry, we spoke on the first part. And then triangular prism is also 1/2 base times height, and then multiply that times the height of the prism. That's what should be right there, by the way. Okay? So just be aware. So if we take a look at number 206, what I would recommend is if they give you a description and there isn't a picture of a shape, draw it. So a fish tank in the shape of a rectangular prism has dimensions, which are in inches. The tank contains 1,680 cubic inches of water. What percent of the fish tank is empty? Now, most people who got this question wrong on the exam didn't use empty, they used the full. So just be careful on this one. So we draw ourselves a rectangular prism. We're going to draw a rectangle inside of a rectangle here. So rectangle, and then another rectangle sort of starting inside of it. Connect your corners. Okay. So if our water level is up to here, going around, right? And the dimensions are 14 by 16 by 10, then we can calculate the entire volume, how much water this should hold, by multiplying the length times the width times the height. Okay? Just grabbing a calculator for myself here. So, (14 times 16 times 10) should give you 2,240. We want we want to know if we fill it, right, let's come back to this. We want to know the percent that's empty. So remember that percent is equal to the part you have over the entire amount, the whole, and then we multiply times 100. So keep in mind, we currently have 1,680 cubic inches of water in here. This thing can hold 2,240. So if we subtract these two numbers, this is what is empty, okay? So this gives us 560 cubic inches of water. So what we're going to do for our percentage is do the empty amount, which is 560, over the total amount it can hold, which is 2,240, and we multiply that times 100. Okay, we are going to get 25%. So that should be choice 2. 207, right next door. Ian needs to replace 2 concrete sections in his sidewalk, as modeled below. Each section is 36 inches by 36 inches by 4 inches deep, and he can mix his own concrete for $3.25 per cubic foot. Ooh, we got a problem right there. How much money will it cost to replace the two concrete sections? So number one, we're talking about cubic feet and it's giving us inches. So we need to make sure we're doing a conversion here. So if we're going to convert 36 inches into feet, we just divide this by 12 because there's 12 inches in a foot. So this turns into 3 feet, and then 4 inches divided by 12 is 1/3 of a foot. All right, so when you're looking at this concrete slab here, okay, it's 3 feet by 3 feet, and then this part, which is the thickness, is 1/3 of a foot. All right, and then how much money will it cost to replace the two concrete sections? There's 2 of these, so we can calculate the volume, right? And then we're going to do the cost. We're going to multiply that times 3.25 per cubic foot. So the volume times 3.25 is going to give us our answer. Now, if you're going to lose points, if you use 36, 36, and 4, so you have to remember we're going to do 3, 3, and then 1/3. And this just equals, well, 1/3 of 3 is 1 times 3 is just 3. So this is 3 cubic feet for each of these sections. Okay? So the total volume is equal to 6 cubic feet. So all we're going to do is multiply 6 times 3.25 for our final answer, which gives us a total cost of $19.50. All right, so it will cost $19.50 to replace. All right. Okay. These next 2 questions involve finding some length of the shape given the volume. So when you're doing these questions, we're going to start with the volume formula, since that's what we're given, okay? And then we're going to solve for the missing piece. So 217, the base of a pyramid is a rectangle, okay? The width is given as 4.6, the length is 9. We now want to know what is the height. So remember the volume formula for a pyramid is 1/3 the area of the base times the height. And we're going to swap out this b, because it's a rectangle, with length times width times height. So the volume, which we know already, so instead of writing a v here, okay, we can replace it with its amount, is 82.8. And then it's 1/3. The length is 9. And times 4.6, and then times h. So if we just do 1/3 of 9, which is just 3 times 4.6, we get 13.8 times h, and then we'll divide out by 13.8 for our answer. And we should get 6. Okay, number 219 to the right. So we have a water cup in the shape of a cone. The height is 4, okay, inches. The diameter is 3 inches. What is the volume of the cup to the nearest 1/10 of a cubic inch? So no need to do any conversions, but it has to be filled to half the height. So this is kind of an interesting one. So if you think about our cone cup here, all right, we currently have a diameter of 3 inches, which basically means, right, that the radius is actually 1.5 inches here. And it has a height of 4 inches. But remember that our cup is technically only filled halfway with water. So the actual height we're worried about is going to be 2 inches. Now, if you thought about this and say, well, if I'm just filling up half the cup, right, then shouldn't the volume just be divided by 2? And the answer is no, you can't do that, okay? Because remember, when you decrease the height, you are also decreasing the radius. So you need to figure out what the new height and radius would be, and then recalculate the volume using that. It doesn't just get divided by 2, because it gets smaller as it goes down. If this were a cylinder and we decreased it, then we could just divide it by that number, but not a cone, because more than one of the dimensions are changing. Okay, so this, right, since it's going down halfway, our radius is also going to decrease by a factor of a half. So like $1.50, half of that is 75 cents. So 0.75 is going to be the length of our radius. And 2 is our height. So the volume, when it's halfway, okay, is going to be 1/3 the area of the base, which is a circle, so pi r squared times h. So volume equals 1/3 pi times the radius, right, we said is 0.75 squared, and then the height is 2. So if we take our calculator, we'll be doing that for our next video here. All right, we're just going to do 1/3 times pi, times pi, all right, times 0.75 squared times 2. Make sure you hit the right arrow to get out of the exponent spot. And we get 1.178. And it does say to the nearest 1/10 of an inch. So we're looking at the 7 here and saying we're rounding up, and we should be picking choice 2. All right. So by the way, if you did the volume, right, and instead of using the 0.75, we used the 1.5. And instead of using the 2, we use the 4. If you just divide this by 2, right, not the same thing here, okay? So because each of these things is decreasing, it's actually going down by 2 cubed, or 8, a factor of 8. All right, Cavaliers Principle. So when we do Cavaliers Principle, key things that we're looking for as graders, when I grade this, or anyone else is grading this, is that they're looking for the phrases area of the base, or cross-sectional area, and the height. You're looking for the phrase about these things being equal. All right, that's the main thing. So if you have two shapes, they're going to have the same volume, equal volumes, when the area of the bases is the same and the heights are the same, okay? Now, when you're doing this question, oh, we didn't need to have this here. Get out of here. I don't know why it's not like a white color, but it isn't. That's okay. All right. So what we're going to say is Sue believes the 2 cylinders shown in the diagram below have equal volumes. Is she correct? So you can actually calculate the volume here, right? It's pi times r, which is 5 squared, times 11.5. And here, because the diameter is 10, the radius is still 5, and the height is not the side length because it's leaning, it's oblique. We use this as our height. So it still has the same radius and the same height. So we can say yes, because remember it says, is she correct? We have to say yes, okay? And then it says explain. That means we have to use some words to do this, okay? So why is she correct? Because the cylinders have the same area of the base, and you can actually tell me what the area of the base is. So that's 25 pi, okay, and the height, 11.5. So the volumes, okay, will be the same, will also be equal. And that's it. Okay, so that's what whenever it mentions Cavaliers Principle or are these the same, that's the phrase we're looking for here. Okay, now we're moving into density questions, or we've kind of already did one before when we talked about the fact that we are using how much money this is worth, kind of a density question as well in disguise. So when we're doing density, remember we use our density triangle, the DMV here. And if you want to know the mass, remember we cover up the M and we're left with density over volume. If we cover up the V, it's density over mass. If we cover up the density because we want to solving for density, it's mass times volume. Okay, so in conversions, make sure that after you find the scale factor of two similar figures, okay, you need to cube the scale factor to find the ratio of the volumes. All right, we'll kind of talk a little bit more about this tomorrow, but we got to keep that in mind. All right, so the scale factor or the ratio of the sides is the volumes when these shapes are similar. All right, is that ratio IO cubed, okay? So if the ratio of the sides is A to B, the ratio of the volumes is A to B cubed. All right, and make sure you convert any units first before you do any calculations, okay? And usually we're going to look at the volume to determine what units we want to be in, or the mass and weight. So you're going to use these units for that, or you're going to determine your final answer to tell you what to convert into. Okay, let's go ahead and get into one here. Now, 227 was a question that was on an exam a few years ago. About half the students did not get this correct because they missed the fact that 2.5 here is in inches and 27 is in feet. So make sure you're careful when you're doing these questions. Okay. Now, if you notice, fabricator hired to make a 27-foot long solid metal railing. It's modeled by a railing of 2.5 inches high, 2.5 inches wide, has a rectangular prism and a half cylinder, and we want to do the nearest cubic inch. So this is telling me that I need to make sure that I am in inches. Keep everything in inches because that's what I needed to calculate the metal here. So if you have 27 feet, when we're turning it into inches, we're going to multiply by 12, because remember, going from a larger to a smaller unit means we get more of that. And 27 times 12 is 324 inches. Okay, so now, in terms of the half cylinder, remember that the height of the cylinder going all the way back is at 324. Okay, the radius going up and down here is half of this, so it's 1.25 is our radius. So the volume of the half cylinder part, okay, is 1/2 pi r squared h. And if you need the formula, remember on the exam, you'll have your formula sheet. You can just pick that out and make sure you do half of it. Okay, so this is equal to 1/2 pi times 1.25 squared times 324. All right, that's the first volume. Then the volume of the rectangular prism is length times width times height. Now be careful on this one because it only goes up this high. This is where it cuts off. So if it was 1.25 to here, there's also 1.25 going from there to there. And then we have the length, okay, the width, and once again, this side is our height. So that's still 324. So when we plug in here, the length is 2.5, the width is 1.25, and the height is 324. All right. So this first one is 0.5 times 1.25 squared times 324 is 253.125, and then the pi is attached still. If you want to multiply the pi out, go ahead. We are going to round to the nearest cubic inch in a minute. And then 2.5 times 1.25 times 324 is 1,020 12.5. So if we add these together, the total, we're just going to add these together. Make sure you attach a pi onto the first number. Plus the second number. And we're going to get 1,807.7. So nearest cubic inch is going to give us 1,808, which should be choice 3. Okay, a shipping container. And the next question is in a right rectangular prism. We want the highlighter, people. The length is 12 feet. The width is 8.5 feet. The height is 4 feet. The container is completely filled with contents that weigh 0.25 pounds per cubic foot. So we don't need to do any conversions because we're in feet. And what is the weight in pounds? Okay, so remember, we're doing the volume question here, and we're talking about rectangular prism. So it's length times width times height. So we just plug 8.5 times 12 times 4. And it doesn't matter the order you put these in. When you're multiplying, you'll get the same answer. That's 408 cubic feet. And so the weight, remember the density, or when you cover up the density part here is what we're looking for. It's the weight times the volume. So we're going to multiply that times 0.25 times the 408. All right, remember your D, M, V. So we're looking for the density, right? We're going to multiply these together. All right, and we end up with a final answer of 102 pounds. All right, on to 243 here with Shay. Recently began kickboxing and purchased training equipment. The diagram below. So the total weight of the bag, the pole, and the unfilled base is 270 pounds. So right now, as is, this whole thing weighs 270 pounds to start with. Okay, the cylindrical base is 18 inches tall. Those are 88 inches. The diameter is 20 inches. Okay, so that means the radius is half of that. And the dry sand used to fill the base weighs 95.64 pounds per cubic foot. Oh, we got a problem. We got inches and feet here, so we got to do the conversion to do. So the nearest pound, determine and state the total weight of the training equipment if we're filling it to 85% of its capacity. Okay, so a couple things we know. We got to convert. Because we're doing pounds and pounds are in feet, we want to convert to feet. So we're going to do that right away. So to do 18 inches and turn that into feet, we're going to divide by 12 to make that happen because there's 12 inches in a foot. So 18 divided by 12 is going to be 1.5 or 3 over 2. And here's the other one that's a little bit rough. Is remember, we're doing the radius of the base, and the radius is 10. So this is not going to be a nice number. So 10 divided by 12, we can just reduce down to 5 over 6. And that's the number of feet. Okay? 5 over 6, by the way, is 0.83 repeating. So if you would rather use this number, make sure you put the little line over the top for that length, that radius here. Now, we're only filling the base up with sand, and we're filling up to 85% of its capacity. So what we need to do first is calculate the volume of the base, okay? Then figure out what 85% of the volume of the base is. And then we're going to figure out the pounds, how many pounds, by multiplying that number times our factor, which is 95.46 by the density there, okay? So let's go ahead and do it. So the volume of the base, because it is a cylinder, is pi r squared h, okay? Remember, we did our conversion already. So it's pi, r is 5 over 6, or 0.83 repeating, squared, and h was 1.5 because we're in feet. Okay, so let's get this crazy number. So we're going to go pi. R, we said was 5 over 6. We are squaring that number, and then we're multiplying it times 1.5. we're going to write down this entire number, okay? Now, this is equal to 3.27249. Even if you wrote this down, this is fine. Don't round it, though, right away, okay? So just write it out. Now, whenever we do the calculation for the next part, we're going to use this entire number, though, okay? So we're going to do 85%, which we need to convert into a decimal. So that's 0.85. Remember, we just moved the decimal point 2 spots to the left there. So 0.85 times, and then just press the up arrow to grab the answer and bring it down. It's 278.1618. 2.78 point, oh, nope, 1618. All right, remember this is in cubic feet. And now I want to figure out the weight, and so the poundage is equal to that 2.781618 times the 95.46. But remember, we're not going to use the rounded number. We're going to use this entire number right here and then multiply that times 95.46. That is the weight we're using, and we're rounding it to the nearest pound, so 265.5 is 266. Now, this is only for the base. We need to figure out what is the weight of the training equipment, okay? So for number 4, for part 4, all right, the weight of the training equipment all right, is, and we're going to add this 266 plus the weight that we started with, which was 270, okay? I don't know why I keep doing that. Sorry about that. So it's 266 plus 270, all right? So just add 270 to that amount and round it is 536 pounds. All right, 535.5, so round up to 536. All right, that's it for today's question. Okay, on to 281. So a gas station, cylindrical fuel tank that holds gasoline for pumps, it's modeled below. The tank holds a maximum of 20,000 gallons of gasoline, and it has a length. Now the length means this part, okay? It's kind of like the height of the cylinder is 34.5 feet. All right, so it holds cylindrical, 20,000 gallons. The length is given. A metal pole is used to measure how much gas is in the tank to the nearest tenth of a foot. So since we're in feet, we don't have to do any conversions. How long does the pole need to be in order to reach the bottom of the tank? And we know that 1 cubic foot is equal to 7.48 gallons. So remember, we're trying to figure out the length of this pole right here. Now, here's the deal. When we have our cylinder, okay, and we're putting a pole into the cylinder here, what we really need to do is figure out the length that this pole is going to go through. That is the diameter. And then it's going to be sticking out plus an extra foot. Now, to calculate the volume, we don't need the diameter necessarily. We actually just need this part from here to here, and that is the radius. So we're going to need to figure out the radius first, okay? That's going to be half the length that the pole is going in. There's going to be another radius that gets us to the top, and then an extra foot. And that's how we're going to get the length of that pole. All right, so we got to do a few things. Number 1, we need to figure out, in order to figure out this amount, we're going to have to use this conversion of gallons to cubic feet. So that cubic feet is going to give us the volume. Once we get the volume, we need to figure out the radius, okay? And then once we get the radius, we're going to do 2 times r plus 1 to get the length of the pole. Because we're in feet already, so we just have to add 1 extra foot to the top of it. All right, so let's do it. So number 1, we got to get the volume. Now it holds 20,000 gallons, so the volume is equal to the gallons divided by 7.48. So volume is going to equal 20,000 divided by 7.48. And so that's this number right there. So 2673.7968. How about that? But remember, we're not going to use the rounded number. We're going to press the up arrow. 2673.7969. All right. And this is in feet cubed. Okay, now we're going to determine the radius by using the volume formula. So remember, the volume formula is pi r squared h. We know h, by the way, is 34.5, and we know that this is our volume. So we're going to do 2673.79679 is equal to pi r squared times that 34.5. Okay, so the first thing we need to do is we need to get r squared by itself, because remember, in order to get rid of the squared, we're going to need to square root. So we're going to have to get the square term alone, which means we divide by 34.5 pi. All right, now options. Okay, we don't want to take this number and then divide it by 34.5 and then put a pi on there. Well, not 24, but 34.5 pi, because the calculator thinks you're just dividing by the 34.5 and leaving the pi being a multiplied, not divided, okay? So option number one, we can use parentheses around 34.5 times pi. Now it moves it to the bottom. Or we're going to do control divide. Go pick that first number on the top, and then you can type in the 34.5 pi on the bottom. One of those two things. Make sure you use parentheses when you have more than one thing in the denominator. Okay, so it's 24.699, let's say 45. I'm just going to, this is kind of all blending together. I'm going to move that r squared down. So we get 24.669, we'll say 45, is equal to r squared. We're going to square root this. Notice we haven't rounded yet. There's no rounding until the very final step, okay? So keep that in mind. So take this. We're going to square root it. So technically, control divide, then up arrow, and grab that. And that's 4.9668. So 4.9668 is equal to the radius. And once again, this is in feet. Okay? So the pole is equal to 2 times that number plus 1. So we do 2 times, grab the whole number, add 1, and it says to round to the nearest tenth of a foot. So 10.9, the next number is 3, and it's going to stay a 9. All right, and technically we'll write down the 10.93367. All right, but we want to round it, so we're going to say the pole is 10.9 feet long. And that's it, because remember, we are rounding using that 3. Okay, that's it for today. There's some extra questions on here and other Regents exams that you can try on your own. All right, however, those are the ones we picked out for today to focus on. So hopefully that helps in terms of what you're doing to calculate the weight and the volume and the density here, and then also being careful to convert calculations right away. Remember, when we're doing Cavaliers Principle, that we're mentioning the area of the base and the height being the same, so the volumes are the same. All right, make use of your calculator, check your units, and hopefully you guys have a great rest of your day. We'll see you tomorrow.